This is Unit 4, Lesson 2, Factoring with Sum and Difference of Perfect Cubes. So by the end of this lesson, you should be able to factor a polynomial that is either the sum or difference of cubes. And you can always multiply the two polynomials back together to prove that it truly was done correctly. So keep in mind, up until this point, we have looked at a variety of types of factoring, and we've looked at difference of squares. So now we're going to bump it up and look at perfect cubes. So one thing to remind you about, for example, when we looked at difference of perfect squares, okay, we knew that we factored into the square root of each. One factor had a minus sign, one factor had a plus sign. All right, to find the square root of a variable, we can just divide our exponent by 2. So really, any variable that has an even exponent is a perfect square. So like if I wanted to factor x to the 10th minus y to the 20th, all right, it's not that, this isn't as challenging as it may first look, but the square root of x to the 10th is x to the 5th. I can just cut it in half. And then the square root of y to the 20th is y to the 10th. All right, because keep in mind when I'm multiplying them back out, when I multiply x to the 5th times x to the 5th, really I can just add my exponents as a shortcut. So which is why when I'm breaking it down, I can divide. All right, so just something to keep in mind. So for perfect squares, we're dividing them by 2. When we get into perfect cubes, any variable with an exponent is a perfect cube as long as the exponent is divisible by 3. Okay, so let's take a look. So there's kind of a pattern here that we use, and it's just something you have to memorize. So like I said before, we now can look at both sums and differences. For perfect squares, you can only factor a difference. You cannot factor a sum of perfect squares. It's not factorable, not over the real set of numbers. All right, but so the factors for a sum or difference of perfect cubes is a pattern. Please memorize them. And to help us with our signs, we're going to use the acronym SOAP. We're going to keep things clean and use SOAP. But we'll come back to that in a minute. So take a look here. I've got a cubed plus b cubed and a cubed minus b cubed. So in both of my examples, I have the same terms. Both are perfect cubes because the cube root of a to the 3rd is just a. You can just divide that exponent. And then the same thing for the b. So the only difference in those two problems, of course, is my signs. When I look at how it's factored out, notice once again, the only difference is the signs. So the actual pattern I'm going to use to figure out what numbers or variables or whatever go in my factoring is the same for sum and difference. Okay, so what I first do is I take the cube root of each of these terms. The cube root of a to the 3rd is a. The cube root of b to the 3rd is b. And I put them right here in a binomial. We'll come back to our signs in a minute. In my second polynomial, which is a trinomial every time, so it's going to be 2 terms times 3 terms, I'm going to take this first thing and I'm going to square it. My first term, and I square it. So a squared is a squared. My middle term right here is going to be these two multiplied together. So a times b, a times b. Okay, we haven't even talked about signs yet, so we're not worrying about our signs. And then my last term is going to be the b squared. Okay, so once again, recap. I took the cube root of each of my original terms, put them in my binomial. Then I squared my first term, multiplied them together, squared the last term. And notice it's the same for whether my problem started off as addition or as a subtraction. Here's where the difference comes into play. It's how my signs get put in there. And we use that acronym SOAP. Same, opposite, always, positive. So when I look right here, since this is a sum of perfect squares, same sign plus the opposite, a minus, always positive, SOAP. When the problem has a minus, same sign, opposite, always positive. Okay, so we have to remember 2 things. We have to remember the method that we use to find our A's and B's and such, and then we need to remember the acronym for our signs. All right, so let's do a couple examples together, and then I'll let you try a few on your own. So let's take a look at x to the 3rd. We'll just start off basic, plus, let's see here. Let's do 27. That is a perfect cube. So let's worry about our signs. Let's take care of them now. Let's get them filled in, okay? So it's going to be a binomial times a trinomial. SOAP, same, this is a plus, so same, opposite, always positive, and I need to fill things in between. So by my binomial, I'm going to take the cube root of each. So the cube root of x to the third is x. The cube root of 27 is 3, right? Because 3 times 3 is 9 times 3 again. Now, I'm using this binomial to help me fill in the other parts of my answer. Okay, so right here, I'm going to take my first term and square it. So x squared is x squared. Right here, I'm going to take those two multiplied together and put it right there. So 3 times x is 3x. And notice I'm ignoring my signs. Okay, the signs don't apply when I'm multiplying them together. Just keep with the SOAP pattern. And my last one is going to be the last term squared. So I square, multiply them together, square again. Now, when you do this, you notice that one of our polynomials is a trinomial. You'll never be able to factor it down further. It won't happen. You can try, but it won't happen. Okay? So that is as far as I can go. That is my answer. That is factored. All right, let's take a look at something like this. Eight x to the cube minus y to the 6. Now, as always, please do keep in mind you need to look for a GCF first. I don't have one here, but we will look at some problems that do. And then, since it's two terms, you're always checking, hey, is that a perfect cube or is that a perfect square? Perfect cubes. 8 is a perfect cube. Cube root is 2. X to the third is a perfect cube. And y to the 6 is actually both, but all right, it falls into the cube category. So, set up your outline. And you can put in your signs if you want to, same, opposite, always positive, or you can do that at the end. Now just be careful here. So the cube root of 8x to the third is 2x. The cube root of y to the 6th is y squared. I got that by dividing my exponent by 3, because I'm doing cubes, groups of 3 groups of the same size. Now, to fill in this first spot, I'm going to square this, the entire thing. So 2x squared is 4x squared. You have to square both the coefficient and the variable. So please be careful. That is a very common mistake to forget about that 2 in front. All right, to fill in my middle spot, I'm now going to multiply these two together. 2x times y squared is 2xy squared. And then to fill in my last spot, I'm squaring the last term. So y squared y times y squared is y to the 4th. All right, and you can always multiply through to check these out, and they should get back to the original. I know it looks like there's a lot more, and I only have 2 terms in my problem, but let me show you what happens. So 2x times 4x squared gives me 8x to the third. 2x times 2xy squared is 4x squared y squared. 2x times y to the 4th is 2x y to the 4th. All right, now I distribute a negative y squared through. So negative y squared times 4x squared gives me negative 4x squared y squared. I've seen that before. Negative y squared times 2xy squared gives me negative 2xy to the 4th. And then negative y squared times y to the 4th gives me negative y to the 6th. So if you notice, these cancel each other. Okay, and these cancel each other, leave me with just the 8x to the third minus y to the 6th. So I know the answer looks a lot bigger than what it should be, considering you only have 2 terms in the problem, but when it's done right and your signs are correct, if you were to multiply back through, they cancel each other out. All right, at this point, there's 4 practice problems. I would like you to pause the video, try them on your own, and I'm going to go ahead and do them too, so when you press play, the answers will be up here. So please go ahead, pause the video, and try these on your own. Pause it. All right, and here you go. You can take a look at the answers. Just a couple things I would like to highlight. Please be careful in the second one. 27, the cube root of 27, x to the 6th is 3x squared. Cube root of 64 is 4. Go through, make sure your signs are all right. Yes, 1 is a perfect cube. 1 is a perfect anything. 1 is just the perfect number. You can take the 5th root of 1 and it's 1. Okay, so don't overthink that. And then in the last example, there was a GCF that you had to pull out because looking at the original problem, 2x to the 3rd is not a perfect square. 2 is not a, perfect cube. 2 is not a perfect cube. And then 16 is not. And when I divide them both by 2, I'm left with x to the 3rd plus 8, which we do know both are perfect cubes. All right, so as always, when I take out a GCF, it does need to be written as part of my answer. All right, that is the end.